Okay, so this is a video about the track problem. So the key to remembering the track problem is that we are dealing with a couple of different shapes here. We're dealing with these two sort of half circles, which all together will form a circle. And then we're dealing with these two rectangles. Okay. And they give us some pertinent information about the track problem. They tell us that this distance from right here to the inside wall of the track is R. Blow this up a little bit. Okay. They also tell us that this distance is twice the width. Now, if half the width is R, then the whole width is 2R, which means this length here is 4R. They also tell us that the track itself is 4 meters wide. So we don't have to deal with this inside piece here, this soccer field piece. We can deal with these rectangles right off the bat. We can do 4 times 4R, which gives us this area of 16R. Now 16R is the area of just this one rectangle here. And we have 2 of these. So we need this one up here, which is also 16R. So now we've taken care of this rectangle too. So now the only thing we have left are these round pieces here on the ends. Okay. Now, if we put them together, let me shrink the track for a second, and let's go ahead and squeeze these two ends together, and we end up with this shape, which, despite my terrible drawing, is meant to be 2 concentric circles. Concentric meaning they're centered in the same place. And the same information applies, right? This is still R. This up here is still 4. So we can say a couple of things about these 2 circles. This whole area. Let me get a nice light color. This whole area, everything. Get a highlighter. This whole area, everything inside this circle can be covered by the equation pi, get black again, pi times r plus 4 squared. It's important that the r plus 4 go in parentheses because they're the new radius. They're the radius of this big circle all out here. It's r and that extra 4. So now if we want to deal with just the inside circle, which is here, that radius is just r. So if we're only interested in getting the shaded portion, which is this, the track portion is just out here, we need to take the area of the whole thing and subtract the area of this middle piece. So it's pi r plus 4 squared minus pi times r squared. So now we have a couple of different pieces. I'm going to shrink this all, and we're going to look at it sort of all together. So our straightaways, if you remember, were 16R and 16R, which if we put together gives us 32R. So that's our straightaways. We can write that over here. Then our circle has this formula right here, which we have to simplify. Now, a lot of students want to make a mistake here by forgetting to do FOIL. Okay? If you have r plus 4 squared, that's r plus 4 times r plus 4 again. So we have to do that out. We have to FOIL that. And when we FOIL it, I'm not going to show you all the steps of FOILing, but just to rush ahead, it's r squared plus 4r plus 4r plus 16, which simplifies to pi times r squared plus 8r plus 16. And we need parentheses around all that because remember it's pi times that and then still minus pi r squared. This is a mess. I'm going to move on to a new slide in a second. Let me go ahead and write this more neatly and get us a little bit more space. So let's shrink this all down and let's just look at the algebra of the problem now. Okay, so now we're at a point where we have pi times r squared plus 8r plus 16 minus pi r squared. Remember, we still have to take out that inner part of that circle and add the two straightaways on, 32r. Now, if we do distributive property with pi, distributing it to each one of these terms, we end up with pi r squared plus 8 pi r plus 16 pi minus pi r squared plus 32r. And we can simplify, because if you notice, we have pi r squared here and negative pi r squared here. Those two are going to cancel out. Which, if we continue to simplify, leaves us with 8 pi r plus 16 pi plus 32r is equal to the area of the track. And that's your final answer.